The chain rule for derivatives, part 2. In the first part of the chain rule, we saw that the derivative of a composite function, f of g of x, equals f prime of g of x times g prime of x. Let's look at another form of the chain rule. What if we want to find the derivative with respect to x of y squared? If we were taking the derivative with respect to x of x squared, we have some rules that we can use. In this case, the power rule, which gives us a derivative of 2x. We can do this because our function is a function of x, and we're taking the derivative with respect to that same variable. But what if our variables don't match? Here I'm taking the derivative of a y function, but with respect to x. What if we did this? What if we did the derivative with respect to y of y squared? Well, I know I can use my power rule because my variables match. But this statement and this one don't agree with each other unless I do the following. Times what? Times dy dx. Now, this is not a true statement. It's not really multiplying by fractions where I can cancel the dy and the dy out like that. But sometimes it helps me to think of it like that so I can do the problem or I can set it up while I'm learning the chain rule. Really, this is a result of our top statement. It might not look the same, but it is the same. So now we can take the derivative of y squared with respect to y, which is 2y, times dy dx, which sometimes we can evaluate, sometimes we leave it like that. That might be part of the answer. So why does this work? Why is this the same thing? Okay. Let's take the derivative with respect to x, and I'll say of y squared. I'll write it like this instead. Notice that I have an outer function, something squared. So if I'm doing this top form, where I say, let's take the derivative of the outside part, power rule, leaving the inside part alone, and this is a 1 right here, so not a prime, so I'll get rid of it like that, times the derivative of the inside part, which is dy dx. So it's another version of the same thing. But when I do derivatives of this form, I usually say the following. If the variables don't match, we must chain out. Let's find the derivative with respect to x of x squared y cubed minus x cubed y squared. So when we're doing derivatives, we have to think of all the different rules we might need. I definitely have products, I have power rules, and I have a derivative with respect to x with some y parts, which means we'll be doing some chain outs. When it gets complicated, all you got to do is one piece at a time. So let's look at this front part. We have a product, which says, let's take the derivative of the first part, x squared with respect to x, 2x, great. Leaving the second part alone, y cubed, plus, leave that first part alone, x squared, times the derivative of y cubed. But we're doing it with respect to x. So we need to do the derivative with respect to x of y cubed. I'll come back to that. We'll get the back part set up. We'll do minus. I'll put parentheses so I don't make a mistake and forget to subtract everything in the back. And we have another product which says, let's take the derivative of the first part, 3x squared, leaving the second part alone, plus, leaving the first part alone, times the derivative of the second part. Now, why am I doing this only with the y's? Because I don't need to do a chain rule when my variables match. Taking the derivative with respect to x of x's, I don't need a chain rule. So let's go ahead and finish it off. So I have 2xy cubed plus x squared. Now, how do I do the derivative of this with respect to x? Well, the derivative of y cubed with respect to y, I know how to do that, but then I need to multiply by dy dx to make my statement match, my expression match. That's the chain out. So this would be 3y squared times what? Well, times the chain out dy dx. Let's get the back part. So minus 3x squared y squared, distributing the negative sign, minus x cubed times what? Well, the derivative of y squared, but with respect to x. So 2y times what? Times the chain out dy dx. And you can clean this up a little bit, but this is the answer. What does dy dx equal? In this problem, I didn't give you enough information to do any more. How about another example? Let's do the derivative with respect to x of, say, sine of x squared plus, let's do 4y cubed. All right. Taking the derivative of this first part, my variables match, so I don't have an extra chain out of dy dx, but I do have a chain rule, kind of the first part, where I have an outer function and an inner function, which says, let's take the derivative of the outer part, cosine, leaving the inside part alone, times the derivative of this inside part, times 2x. If I can, I like to put it out front. So we're done with the derivative of the first part. Variables match. I don't need an extra chain out. But now the second part, we're taking the derivative of a y with respect to x. So there will be a chain out. But we can use our normal rules. So 12y squared. And here's where the chain out comes in, times dy dx. Okay, let's do one more, but let's throw a bit of a twist at you. Let's take the derivative with respect to t of x times cosine y, product rule, I'm already seeing it, plus the square root of x squared minus 1. Do we need a chain rule? We'll see. Minus y cubed. And do we need a chain rule in the back part? All right. Let's do the derivative in pieces. So we have a product, which means we need to do a product rule. The derivative of x is 1, but my variable doesn't match. I'm not doing dx with respect to x. I'm doing dx with respect to t. So I need a chain out. What's my chain out? Well, dx dt. Leaving the second part alone, plus. So no chain out on the cosine of y because we're not taking a derivative. We left it alone. Now plus x, leave it alone. No derivative, no chain out. And we'll do the derivative of the cosine of y, which is negative sine y. But my variable doesn't match. I'm taking the derivative of y with respect to t, so I need a dy dt. Continuing on, taking the derivative of the square root of x squared minus 1, which is 1 over the square root of x squared minus 1, and then 2 out there, right? So 1 over 2 root the thing times the derivative of the inside part. So this is a chain rule just with respect to the x. But I took the derivative of x with respect to t, so I need a chain out of dx dt. And one last piece, I'll put it down below. So minus, I know that the derivative of y cubed is 3y squared. But my variable doesn't match. I have y with respect to t, so I need to take the derivative, or the chain out, dy dt. So kind of in general, I'll do something like this. Dy dt x squared plus y cubed plus z to the fourth minus w to the fifth. If I'm taking the derivative of a function with respect to a different variable, I will have to have the chain out of that function with respect to that variable, like this. I'm going to have 2x. Variables don't match, so dx dt. Why is it not dt dx? Because I got the dt on the bottom. Now there's more to it, but this is just a quick way to know how to do the chain out. And then plus 3y squared. Variable doesn't match. Y with respect to t, so I do times y with respect to t. Continue on, 4z cubed times dz dt minus 5w to the fourth times dw dt.